All right, let's dive right into this. Welcome to today's Explainer, where we're going to unpack something I like to call the friction of the AI frontier. You know, we hear constantly about the magic of artificial intelligence, but behind the scenes, this massive, just completely insatiable demand for AI compute is seriously stressing the system. And I mean the whole shebang, from our physical hardware supply chains and global economics, right down to the software we're using every day, and even unprecedented new government regulations. We are actively testing the absolute limits of the system here. So here is our roadmap for today's Explainer to make sense of it all. We'll start with the AI hardware squeeze, then check out IBM's nano breakthrough, shift gears to geopolitics with the new AI regulators, and wrap up with a segment I call the good and the slop. Let's connect the dots. Section 1. The AI hardware squeeze. We're talking global bottlenecks. Now, the abstract demands of these massive data centers can feel completely disconnected from our daily lives, right? But $200. That is exactly how much the base price of a MacBook Air just jumped, going from $1199 to $1299. Why? Because the aggressive expansion of AI data centers has triggered an extraordinary global surge in demand for memory and storage. The tech giants are basically buying up all the memory chips to build out their infrastructure, and it's our everyday consumer devices that end up paying the price. And this Apple pricing move from Thursday brilliantly illustrates just how steep that impact really is. It's not just the Mac. The entry-level iPad Air, that jumped from $599 to $749. We're talking about price hikes of 20% or more across their major hardware lineups. The sheer financial pressure of securing these memory components has absolutely forced companies into a corner, and they're having to look for pretty drastic and sometimes controversial solutions just to keep their supply chains intact. Which brings us to this incredibly revealing quote from Apple CEO Tim Cook. He recently told the Wall Street Journal that price hikes were inevitable, and when he was pressed about sourcing materials, he said, "I think everything needs to be on the table. I think we should look at all supply." Well, behind the scenes, to ease this unsustainable financial squeeze, Apple has actually started lobbying the Trump administration for clearance to buy memory chips from a Chinese supplier called Chongqing Memory Technologies, or CXMT for short. But here's the massive catch. CXMT is on the Pentagon's Section 1260H list, which is a blacklist of alleged Chinese military companies. Now, just to be precise and entirely objective here, Apple isn't technically barred from buying CXMT chips right now. The designation currently just prohibits the U.S. Defense Department from contracting with those companies, and the third-party procurement bans don't actually kick in until June 2027. However, simply being on this list creates immense regulatory friction and serious reputational risk. U.S. companies are, understandably, super wary of doing business with anyone on this list without explicit government approval. And that's exactly why Apple is expanding its lobbying campaign in Washington right now. The hardware squeeze is quite literally forcing geopolitical hands. Moving to Section 2, IBM's Nano breakthrough. Time for some engineering solutions. So, if physical space and memory are maxed out, how do we fix it? Well, on June 25th, IBM's research division announced a massive game changer. Traditionally, you build chips by spreading transistors flat across the surface, but IBM developed something called a nanostack architecture. Instead of spreading out, they're building up. They are vertically stacking transistors in 3 dimensions. Think of it like the difference between building a sprawling suburban neighborhood versus constructing a dense, highly efficient skyscraper. The absolutely crucial point here is the sheer scale they've achieved with this skyscraper approach. On a 0.7-nanometer prototype, a chip literally the size of your fingernail, IBM managed to pack nearly 100 billion transistors. That's roughly double the density of their 2021 chips. This architecture promises up to 50% more performance or 70% better energy efficiency. If you're an AI accelerator built on this design, you're hitting roughly 9,000 trillion operations per second. That's about 6 times faster than the chips driving today's AI boom. And this exponential leap in processing power and efficiency, it means the training time for massive frontier AI models could compress from a grueling 3 months down to just 2 weeks. This is exactly the kind of leap that actually relieves the hardware strain we were just talking about. IBM says this tech could reach commercial production within 5 years through licensing partners like Intel and Japan's Rapidas. So there is definitely a huge light at the end of the supply chain tunnel. All right, Section 3, the new AI regulators. Let's look at the geopolitical stakes. Because as these models get faster and smarter, the geopolitical stakes just keep rising. We are currently witnessing a really unprecedented intervention in the commercial tech industry. Just recently, the US government put an export control block on Anthropic's Claude Mythos 5 AI model. That kicked off a very tense 2-week standoff featuring intense daily talks between the company and the government. Finally, Commerce Secretary Howard Lutnick partially lifted the block. He sent a letter to Anthropic's Tom Brown confirming that appropriate safeguards are in place, which allowed Anthropic to release the model to over 100 trusted U.S. partners, like major companies and government agencies, without needing special export licenses for those specific groups. The big takeaway? The U.S. government now exerts direct control over commercial frontier AI releases. Anthropic has even committed to working with the government on protocols and standards for its future models. Now, whether you view this as absolutely crucial for national security or as a heavy-handed intervention, the objective fact is that this establishes a brand new regulatory framework. It fundamentally changes the dynamic of the entire commercial tech industry. Washington is now sitting right at the release valve for frontier AI.
Okay, final section, the good and the slop. Let's talk real-world software applications.
We've talked about multi-billion-dollar hardware and high-stakes government showdowns, but how does all this insane compute power actually translate to the consumer software you and I use every single day? Well, what happens when AI doesn't look before it leaps? Or more accurately, what happens when a massive tech company forces an AI tool onto its advertisers without double-checking the output? We got a pretty hilarious, kind of disastrous answer to that this week involving Meta and the outdoor retailer REI. Meta automatically enrolled REI in an AI personalization tool that was supposed to dynamically adjust product photos for Instagram ads. But instead of optimizing the ad, the AI just completely mangled a professional photo of cyclist Amity Rockwell standing next to a Van Rysel bicycle. It generated absolute physical impossibilities. It literally created drop handlebars sticking straight out of the back of the seat. It slapped both disc brakes and rim brakes onto the same bike, and it completely misrouted the bicycle chain. Somehow REI missed it, and this totally deformed, impossible image ran as an actual ad for about 5 days before social media users spotted it and forced them to pull it. Which naturally led to the internet doing exactly what the internet does best. This quote from a Reddit user just perfectly hits the nail on the head. There's using AI slope, and then there's not even looking at the slop before posting it. It's a really funny, slightly embarrassing anecdote, but it brilliantly illustrates a much bigger point. You can spend billions on memory chips, you can stack 100 billion transistors in 3D, and you can navigate complex government clearances, but at the end of the day, frontier AI still fundamentally requires human common sense and oversight.
But hey, it's definitely not all mangled bicycles. Let's hit our final data point and look at how everyday tools are successfully leveling up. On June 26th, Google dropped a Gemini update with 5 major new features. We got real-time image generation and editing using their Nano Banana engine, which, by the way, is a fantastic name. They integrated Gemini directly into Google Business Profiles in the Android Play Store. They added 12 soccer-themed templates for the 2026 World Cup, and they rolled out a thinking levels reasoning control option across all platforms. So, despite all the friction we've discussed today, relentless consumer innovation is still charging forward at breakneck speed. Which brings us to the ultimate question I want you to take away from this explainer today. As AI demand explodes, how will we balance this relentless innovation with hardware limits and unprecedented government oversight? We are quite literally running out of physical memory, forcing massive tech companies to navigate incredibly tricky geopolitical waters. We're inventing microscopic 3D skyscrapers just to compute faster. And governments are stepping in to tightly control what actually gets released. The frontier is moving so fast, but the friction is very, very real. Thank you so much for joining me to connect the dots today. Keep learning, keep questioning, and I'll see you next time.